Good day, or good evening, whatever it is. Today we're doing something a little more concrete today, and that's set operations. This will be familiar to some of you, so I think this will be a welcome break from the abstract stuff we've been doing. So what are set operations? Basically, the operations between sets allow us to talk about relationships between the sets we're interested in. That's basically why we have set operations. So I'm going to make up two sets. Set A containing these lowercase letters, and set B containing these lowercase letters. And I'm just curious about something. If I were to do this, put the sets together, meaning combine them, then what distinct elements would exist in the new set? So if I put these two sets together into one set, what would be the list of distinct elements in that set? So of course I would have an A, but I'm only asking for distinct elements, so I don't have to list A twice. And then I'd have a B and a C, which I would only list once, and a D. So this would be the combined set of sets A and B. And we call this a union. So this is the union of A and B equals that. Okay. Now this English is a little wordy, so in symbolic language, this is how we would write the union of A and B. This symbol right here. A union B. The union of A and B is A, B, C, D. Okay, now I also am interested in, are there any elements in these two sets that exist in both of the sets at the same time? Are there any elements that the two sets have in common? So any elements in common, meaning in the original two sets. And yes, yes, they both have an A and they both have a C. So this is called the intersection of A and B. And that symbol is this one. You just turn the U upside down. The intersection of A and B is A and C, the only two elements that appear in both sets. Okay, so far we have two set operations, union and intersection. Now I can play around with these union and intersections a little bit. Let's say I make up a third set, D, E, F. And I'm still going to use set A up here, the original set A. And I'm interested in the intersection of A and C. The intersection of A and C. Well, A had A, B, C, and C has D, E, F. You can see that right here. So they don't have anything in common. So I have no elements to list in between the braces. So what is their intersection? Empty set. Or, if you prefer, the other symbol, empty set. So empty set can be an answer. Empty set is a thing. It's a set without elements, but it's still a thing. Now, I can also play around with actual sets with real numbers that we know of, like the infinite sets that we discussed last time. So if you need to take out your list of symbols for the infinite sets, go ahead, because I'm going to use only their symbols right now. Q, which is rationals, union, I, which is irrationals. Union means put the elements together. So if I put the elements of all the rationals with all of the irrationals, what infinite set do I get? I get the reals. What if I take all the reals and I intersect them with the imaginaries? Well, no, there are no imaginaries that are real, and there are no reals that are imaginary. So the intersection is empty set. Okay, what if I take all the integers, union them with wholes? Now these two sets do share some numbers. The wholes are 0 and all the positive integers, and then z is all the integers. So if I put them all together, and I only care about the distinct ones that exist when I put them all together, the union is just going to be the same as whichever one of these is the larger set, and that's integers. What about the intersection of naturals and wholes? So this is just the elements that are in common. The only ones that n and w have in common are 1, 2, 3, 4, 5, ... right? Not the 0. So I can summarize that as naturals. Okay. You can ponder that for a while if you need to in the future. I'm going to move on to the next operation, which is the difference operation. You can think of this as the answer to the question, what are the elements in the first set but not in the second? What are the elements in the first set but not in the second? So I'm tired of using the same set, so I'm going to change set A. I'm going to make it 2, 4, 5, 6, and I'm going to make set B 3, 2, 3, 5, 7. Okay. Now, the difference symbol is just a minus. So A minus B means what are the elements in A that are not in B? What are the elements in A that are not in B? I don't care about the ones that are in B and not in A, just the ones that are in A and not in B, because A came first. So I do a quick scan, and I notice they both have 2. I have a 4 here, but not here. So that's one of them. I have a 5 in both. I have a 6 here, and not here. So 4 and 6. Just 4 and 6. Let's turn it around and find B minus A. They both have 2. So that doesn't matter. B has a 3. They both have 5. B has a 7. So B minus A is the set with 3 and 7. Okay, we're going to move on to something called the universal set. The universal set is not, it's not an operation, it's actually a set, but it allows us to use another operation. Without the universal set, we can't use the next operation that I'm going to explain. So what is the universal set? Why do we have a universal set? It sets boundaries for what elements are available. So if I only want the naturals from 1 to 10 to be available for use, I can set a boundary and say that, okay, the only numbers we're allowed to use in this temporary universal set is 1 through 10. Okay, so the person in charge or the problem in charge gets to decide what's in the universal set. So I'm going to put a capital U here so that you know that this rectangle is going to represent the universal set. And inside the universal set, I'm going to put some letters. Scattered around. And I'm going to create some sets that contain some of these elements. So here I'm going to have a set here that contains AEF, and I'm going to have another set here that contains CDF. And I'll call this one set A, and I'll call this one set B. Okay, so let's keep in mind that the universal set, all elements that are available for use are A, B, C, D, E, F, G. And A is A, E, F. And B is C, D, F. Okay? Now, I listed these three sets that make it look like they're all same level, same rank sets, but they're not. Remember, the universal set, that's the general. That's the general. That's the admiral. And then these are sets inside the universal set. Okay. Now, now I can use another operation called complement. So what does complement mean? It's basically the elements in the universal set that are not present in a set. So the symbol for complement is an apostrophe. So this is read the complement of A. The complement of A. So in the complement of A, I'm going to list the elements that are not in A, but are in the universal set, that are in the universe. They just happen to not be in set A. So you can either look at the Venn diagram or you can look here. We'll start with the diagram. Set A has AEF. What are the elements that are in the universe that are not in A? So in no particular order, G, B, C, D are not in A. I like putting them, B, C, D, G. That would be alphabetical order. There is the complement of A. What about B? The complement of B would be all the elements that are not in B, which are in alphabetical order A, B, E, G. Now you can start to do two-step operations now. That's the intersection. Here's the intersection of A and B, but I want more than just the intersection of A and B. How about the complement of the intersection of A and B? Okay, so first you got to know what the intersection of A and B is. Then you take the complement of whatever that is. So I'll do a little scratch work here. A intersection B. That's just F. That's just F. The complement is going to be everything but F. So in the end, the complement of the intersection of A and B is A, B, C, D, E, G. Everything but F. Okay, let's try it with union. The union of A and B is all the elements together taken from A and B. That would be everything in here. So it's a lot. But I want the complement of that. So first let's do the union. A, C, D, E, F. That's the union. And then I take the complement, which is just B and G. I can also just look at the picture here. Just look at what is not circled. B and G. Okay, so that's complement. And there are simple exercises that I'll assign for classwork or homework on this. That's it for set operations. And thank you, and we'll see you next time.